Hello, hello, Mr. Waddy here, and we're talking about Algebra 1, Chapter 9, Section 2, solving quadratics by graphing. Yes, quite unusual. And so notice, here is a quadratic equation. Here is a quadratic function. Those are pretty similar to each other. In fact, we call them related because pretty much all I did was I took the equation part, had it set equal to 0, and I took that same equation, set it equal to y. And if I graph the related function, it turns out that the x-intercepts will be the solutions of the original equation. And so the x-intercepts here, the x-int occurred at -1 and at +3. And those also will be the solutions of the original. So x equals -1, +3, final answer. You don't have to write that step. I'm just educational purposes only. Here we go. Solve this equation. Nice. So let's, this one's already set equal to 0. So I'm going to write y equals x squared minus 2x plus 5. So this is the related function. And let's, it's a quadratic. So I'm going to have to graph this quadratic, and so it's got a b term. So I'm gonna do the a equals and the b equals, right? The -2 there, and the c equals 5. Hey, the y-intercept is 5. And by the way, I'm graphing this pretty quickly. Go back and check out my Algebra 1 Chapter 8 videos if you want to see how to graph some of these. This is in standard form, ax squared plus bx plus c sort of stuff. So I'm going to speed run some of this. Just get to the new concept, solving equations by graphing. So h equals -b over 2a. So that's the opposite of -2 over 2 times 1, right? B and a right there. H is going to be the x coordinate of my vertex, and I got h equals 1. Now to find the y coordinate of the vertex k, I take this one and I plug it in everywhere I see an x. And so x squared minus 2x plus 5. Let's plug in a 1 for those x's. 1 squared is 1, minus 2 plus 5. 1 minus 2 is -1 plus 5. And I get k equals 4. And so my vertex occurs at over 1, up 4. Aha, wow, something unusual is happening already. Because I'm seeing, here's the vertex, here's one of my points, and the rest of this we could figure out using the slopes. Since a is 1, it's a regularly shaped parabola. And so the slopes are up 1 over 1, up 3 over 1, up 5 over 1. And if I mirror those points, notice this is what I get. I draw the parabola, and whatever my x-intercepts are will be the solutions. Now, wait a minute. There are no x-intercepts. No x-intercepts. Metal Gear Solid alert sound. Therefore, this equation has no real solution. Boom. Donezo. All right, so that's the trick. You set your equation equal to 0, graph, and then, right, take that equation, set it equal to y, graph it however you can, whatever the shape, and find the x-intercepts, and those are your solutions. Here's another one. Tell you what, let's use method. I'll do both methods. Method 1. Boom. And yeah, I realize I just wrote meth 1 on my YouTube channel. That's fine. That's fine. Add 2x to both sides, so I get plus 2x. Add 1 to both sides. Boom. That's equal to 0. The related equation, the related function, is now y equals x squared plus 2x plus 1. And, all right, you guys are good at finding a, b, and c and all that. So to find h, it's the opposite, -b over 2a. So the opposite of 2 over 2 times a, which is 1. I get h equals -2 over 2, which is -1. So there's the x coordinate of the vertex. K is going to be this plugged in for those. And so I'll have -1 squared plus 2 times -1 plus 1. -1 all squared is positive. Oh, you don't say. I get k equals 0 here. Interesting. So my vertex is -1, 0. The slopes of this were the usual, up 1 over 1, up 3 over 1, etc. And then mirror, right, up 1 backwards 1, up 3 backwards 1. And I draw that parabola, and notice, what are the x-intercepts? Well, there's only one x-intercept. What? And so the x-int is -1, and whatever the x-intercept is of the graph will be the solution of the equations. And so I got x equals 1. Now, method 2. Same idea, except I take each half and I graph those as two separate functions. So I'd have y equals x squared, and I'd have y equals, I'm going to write that as -2x minus 1. And if I graph those, I'm making squinty eyes at the screen here. Guys. All right. I'm just going to graph this in red. All right. And so this one had a vertex here, up 1 over 1, up 3 over 1, etc. It's just a horizontal shift, notice. And so there's that parabola. And then if I graph the line, notice y equals mx plus b. What's funny is I believe you're better at graphing quadratics than you are at graphing lines, because we've been doing it more recently, that I'm actually taking more time to do this one. So the y-intercept would have been -1, right? And the slope is -2. And so I would have gone right down 2 over 1, or the same as going up 2 backwards 1, up 2 backwards 1, up 2 backwards 1. Do I have my line tool? I do. Sweet. Because, yeah, otherwise this was going to be garbage with so many things plotted on the same grid. And I was graphing this in orange, was I? And so here's the graph. Now, a little bit broken because this parabola, the red parabola, technically hit in 2 spots. But the real intersection was right there, which notice was the point -1, 1 is the intersection between the orange line and the red parabola. So this is method 2. I wouldn't have done method 1 if I was only doing method 2. All right. And so whatever the x coordinate of that intersection is will be the solution of the original equation. And so once again, I get x equals, wait a minute. Oh, guys, I hope someone caught this mistake. That was a -1. Yeah, just transcription error right there. So x equals -1, whichever way. So what's nice about method 2 is you just take each half of the equation and write them as their own line. Now, it can be simpler graphs, right? And so, yeah, if this was like a 3, for instance, then I would have had weird fractions for my vertex. It would have been garbage. But if this was the 3 here, graphing a line wouldn't have actually been that bad. So sometimes method 2 will be much faster. Here we go. Modeling. The height of an underhand volleyball serve can be modeled by this equation, where t is in seconds and h is the height in feet. Do both t-intercepts of the graph of the function have meaning in this situation? So the answer to A is no. -0.125 seconds does not make sense. Right? That was before we would have started gathering information. Really, the person who's like, here, ooh, I'll draw a picture. Here's the person. They're underhanding their volleyball. Wah! Right? The first point of contact with the volleyball right there would have occurred at whatever that y-intercept is, which happens to be 4 feet. Haha, I found it. And so, yeah, time before they started would not make sense. It didn't necessarily ever touch the ground at that time. Maybe the person was just holding it for a while. No one receives the serve after how many seconds does the volleyball hit the ground? And so which one is, let's see, which one is seconds? Seconds is time. Time is this axis. The height axis was this one, right? And so here, this point represents when the height was 0, which I don't know about you, but that's what I call the ground. And the time at 0 was 2. And so 2 seconds is when that occurs. Now, they didn't ask any fancier questions, but they could have asked something like, oh, how long does it take to reach the maximum height? We could have even figured out what is the maximum height, which, by the way, I could calculate using the vertex. But we won't do that right now. I think I've got one more problem. No, 2 more problems. All right, this one's fast. Find the zeros of the graph. Boom. Boom. Hey, this one was a ricochet, so it counts as 2. So I'd get x equals -3 and 1. Boom. But these swoopty curves could have hit as many as 3 times. Here we go. All right, approximate the zeros of the function. I've already got this graphed, and I've already got a table for you. Now remember, so this x-intercept occurred somewhere between -1 and 0. This x-intercept occurred somewhere between 2 and 3. And so notice I picked x values that were between those numbers. All right. Also, I could tell that it was a little bit to the right of the middle between those. And so notice I started from -0.5. Now, when does it cross the axis? Well, we analyzed that based on sign change. So notice all of these parts of the parabola were negative, right? Negative. All of these parts of the parabola are negative. These parts are negative. And all of this is positive. And all of this was positive. And so graphically, it's easy to see it's positive whenever it's above the axis. It's negative whenever it's below the axis. Looking at a table, how do I identify that? Well, it's negative anytime it's negative, and it's positive anytime it's positive. Boom. And why is that helpful? Well, when trying to find where it crosses the axis, it's going to occur anytime the sign goes from negative to positive or positive to negative. And so that occurs in between here. Now, I'm approximating to the nearest tenth. Notice these are already in the tenths place. Which of these is closer to 0? Well, 0.04 is closer to 0. So one of my solutions is about, x is about -0.4. Whenever I repeat myself, I feel like Khan Academy. Let's see, the other sign change occurred here and here because it went from positive to negative, right? Instead of negative to positive. And which one was closer to 0? Well, this one was, so 2.4 is my other approximate solution. And so solving by graphing, you can get approximate solutions. This original problem would not have been factorable. It would have been impossible to solve using this strategy. And so this is our first time kind of seeing how can you solve when you have answers that are non-integer, if you will. Was I going to say something else fun about this problem? Something interesting? Oh, that's what I was going to say. I already gave you the table. The way you could have generated the table is by hand or with a calculator. Actually figure out what happens when I plug in. Man, I didn't give myself enough room. -0.5 for every x in this equation. Oh my goodness. It would have been horrible. And so you're welcome that I already pre-calculated this out for you. There you are. And if you're doing this only on big ideas, go check out the notes packet where this table is already generated for you. That'll save you a lot of time. All right, thanks for watching, Internet friends. Calc you later.